Penalized regression method functions by adding a penalty term to the standard linear regression to prevent overfitting, manage multicollinearity, and improve the model generalizability. Penalized regression. Penalized regression is a group of regression techniques like rigid lasso, elastic net that improve predictions and feature selection in the models, especially with high dimensional data. By adding up penalty terms to the standard loss function to shrink coefficient towards zero, preventing overfitting and improving model generalizations. Penalized regression methods are widely used in medical sciences to handle high dimensional data where the number of predictors p is much larger than the sample size n. For example, in genomics and the prevent overfitting, these methods work by adding a penalty to the standard regression equation which shrink the regression coefficients towards zero. Health example. Identify genetic markers for cancer. A common application is in cancer genomics, where researchers analyze thousands of genes expressions to predict a patient's prognosis or survival time. Goal: to identify which of the thousands of potential genes are most associated with the patient's survivals and build a predictive model. Challenge: standard linear or logistic regression fails when there are more predictors than patients, or when many predictors are highly correlated genes in the same biological pathway. Lasso regression least absolute shrinkage and selection operator applies a penalty that can shrink some coefficients to exactly zero. The means lasso performs automatic feature selection, creating simpler, more interpretable models by effectively eliminating uninformative predictors. For example, in a study using clinical variables and laboratory blood tests to predict the results of COVID-19, PCR test lasso was used to select the most relevant features, leukocytes, basophils, and C reactive protein, and eliminate other, resulting in the simpler, high accurate model. In cancer research, it can help identify a small set of rigid regression shrinks all coefficients towards zero but never makes them exactly zero, resulting in a model that includes all variables but gives less weight to irrelevant ones. It is effective at managing multicollinearity. For example, in a study predicting patient survival from a large set of genes expressions data, rigid regression might be used to stabilize the model when many genes have a small but non-zero effect on the outcomes. It would remain all genes in the final models, but those with little impact would have coefficients very close to zero. Elastic net regression, lasso and rigid penalty. Elastic net combine the both lasso and rigid penalties, providing a balance between their strengths. It performs variable selections like Lasso but is better at handling groups of high correlated variables by tending to keep or remove them as a group rather than picking just one randomly. For example, in an analysis of infant mortality rates in Indonesia, the elastic net method was found to be the most accurate in the modeling data with high multicollinearity among social and environmental factors, sanitation, nutrition workers, human development index. It ensured that if several correlated factors were important, they were all considered together in the model. In summary, penalized regression allows health scientists to build reliable predictive models even with complex data, offering stability, interpretability through variable selection, robustness to correlation.